From the earliest humans gazing at birds soaring across the sky, the dream of flight has captivated our imagination. We long to touch the clouds, to experience the freedom of soaring above the earth. The invention of the airplane marked a pivotal moment in human history. It transformed the way we travel and connect with each other. A delicate dance of forces allows us to navigate the invisible ocean above. To understand the marvel of flight, we must first grasp the four fundamental forces at play: lift, weight, thrust, and drag. These forces, constantly interacting, determine whether an aircraft climbs, descends, accelerates, or maintains a steady course through the sky. Weight. The most intuitive of these forces is the force exerted by gravity on the airplane. It acts downwards, pulling the aircraft towards the earth. Opposing weight is lift, the force that counteracts gravity and allows the plane to stay aloft. Lift is generated by the wings and acts perpendicular to the direction of flight. Thrust, generated by the airplane's engines, propels the aircraft forward. It overcomes the force of drag, which is the resistance the airplane encounters as it moves through the air. Drag acts in the opposite direction of thrust, attempting to slow the aircraft down. These four forces, in a constant state of dynamic equilibrium, dictate an aircraft's motion. When lift exceeds weight, the plane climbs. When thrust surpasses drag, it accelerates. When these forces are balanced, the airplane maintains a steady, level flight. The key to flight lies in understanding lift, the force that counteracts gravity and keeps airplanes suspended in the air. How do wings, those seemingly simple structures, generate enough lift to overcome the weight of an entire aircraft? The answer lies in their ingenious shape and the principles of fluid dynamics. An airplane wing is not a flat surface. It's carefully sculpted with a curved upper surface and a relatively flat lower surface. This shape, known as an airfoil, is crucial for generating lift. As the airplane moves forward, the airfoil slices through the air, diverting the flow of air around it. This diversion of air is the key to lift generation. The curved upper surface forces the air traveling over it to travel a longer distance than the air flowing under the wing. To meet up again behind the wing, the air above the wing has to travel faster. This difference in airspeed above and below the wing creates a difference in air pressure. The relationship between airspeed and air pressure is explained by Bernoulli's principle, a fundamental concept in fluid dynamics. It states that as the speed of a fluid increases, its pressure decreases, and vice versa. In the context of an airplane wing, the faster-moving air above the wing creates a region of low pressure, while the slower-moving air below creates a region of high pressure. This pressure difference generates an upward force on the wing, lifting the airplane. The higher the airspeed, the greater the pressure difference and the greater the lift generated. This is why airplanes need to achieve a certain speed before they can take off. But Bernoulli's principle alone doesn't tell the whole story of lift. Newton's third law of motion, which states that for every action there is an equal and opposite reaction, also plays a crucial role. As the wing deflects the air downwards, the air in turn exerts an equal and opposite force upwards on the wing, further contributing to lift. Section 5. The power of thrust. While lift counters gravity, thrust is the force that propels the airplane forward, allowing it to achieve the airspeed necessary for lift generation and to overcome the ever-present force of drag. This forward force is typically generated by jet engines, marvels of engineering that utilize the principles of combustion and fluid dynamics to create powerful thrust. Jet engines work by drawing in vast quantities of air and mixing it with fuel. This mixture is then ignited in a combustion chamber, causing a rapid expansion of gases. These hot, expanding gases are then forced out of the back of the engine through a nozzle, creating a powerful jet of thrust. This thrust, according to Newton's third law of motion, is the reaction to the force of the hot gases being expelled rearward. The greater the mass of air and fuel passing through the engine, and the faster the exhaust velocity of these gases, the greater the thrust produced. Section 6. Aerodynamics, the shape of flight. Beyond the four fundamental forces, the science of aerodynamics plays a crucial role in ensuring a stable and controlled flight. Aerodynamics is the study of how air flows around objects, and in the context of aviation, it encompasses the design and optimization of aircraft structures to minimize drag and maximize stability. The shape of an airplane, from its sleek fuselage to its swept-back wings and stabilizing tail, is carefully engineered to minimize drag, allowing it to move through the air with minimal resistance. This streamlining reduces fuel consumption and increases the airplane's efficiency. Stability is another crucial factor in flight. Just as a weather vane always points into the wind, airplanes are designed to maintain a stable orientation during flight. This stability is achieved through the careful placement of control surfaces on the wings and tail, which can be adjusted to manipulate airflow and maintain a level flight path. Section 7. Taking off and touching down. Takeoff and landing are the most critical phases of flight. During takeoff, the airplane must generate enough lift to become airborne. The pilot increases engine power, generating thrust. Landing is essentially the reverse of takeoff. The pilot reduces engine power, allowing the airplane to descend. Upon touchdown, the pilot applies brakes to bring the airplane to a safe stop. Section 8. A triumph of human ingenuity. The ability to fly, once a distant dream confined to the realm of mythology and imagination, is now a testament to the power of human ingenuity. Through centuries of observation, experimentation, and relentless pursuit of knowledge, we unlock the secrets of the sky, transforming how we live, work, and connect with each other. From the Wright brothers' first tentative flight at Kitty Hawk to the sophisticated aircraft that now crisscross the globe, the story of aviation is a testament to the boundless potential of the human spirit. It serves as a constant reminder that the only limitations we face are those we impose on ourselves. As we venture further into the 21st century, the dream of flight continues to evolve. We strive to create even more efficient, sustainable, and accessible forms of air travel, pushing the boundaries of engineering and design. With each new innovation, we reaffirm our commitment to exploration and our unyielding desire to reach for the stars. Pause 3S. Section 9. Looking to the future. As we stand on the precipice of a new era in aviation, the horizon is filled with possibilities. Emerging technologies, from electric propulsion to autonomous flight systems, promise to revolutionize the way we think about air travel. Companies and researchers around the globe are working tirelessly to make air travel faster, safer, and more environmentally friendly. Imagine a world where air taxis whisk us across cities, or where supersonic jets make intercontinental travel a matter of hours, not days. The future of flight is not just about reaching new heights, but about making the skies accessible to everyone, ensuring that the dream of flight continues to inspire future generations. As we look to the future, we do so with the same spirit of innovation and determination that has driven us from the sands of Kitty Hawk to the edges of space. Thanks for watching. Don't forget to subscribe.